Welcome to the .NET Excel Library tutorial. In this video, I will show you how to build an AI-powered Excel translator using the Syncfusion .NET Excel Library. This includes creating a C# console application, configuring Azure OpenAI, and generating a translated Excel file. The prerequisites for this tutorial are Visual Studio 2022 or later, and the .NET 9.0 SDK or later, and the necessary credentials for your Azure OpenAI account. Now, let's move on to creating the console application in Visual Studio. I open Visual Studio and select Create a new project from the dashboard. From the list of templates, select Console App and click Next to continue. Then, I enter the project name and click Next again. I proceed with the default configuration and click Create to generate the application. Project is now ready to use. I open the NuGet Package Manager and navigate to the Browse tab. I search for the Syncfusion XLSIO Net Core package. Click Install and choose Apply to add the package to the solution. Then, I search for Azure AI OpenAI. Click Install. This enables the .NET application to connect to Azure OpenAI models to generate the translated Excel file. This is the document I will use in this example. It contains sales performance data across different regions and products. I open the program CS file and import the required namespaces for the application. The Syncfusion XLSIO package is used to work with Excel files, specifically for reading Excel data. The Azure AI OpenAI package is used to connect the application to Azure OpenAI services. The OpenAI chat namespace serves as a communication bridge between the application and the AI model, and the system client model is used for API authentication. In the main method, I define a string variable to store the Azure OpenAI API key. I have already configured Azure OpenAI. You can use your own credentials here. Next, I define a method called execute translation that handles the translation process. Inside this method, I use console WriteLine to display a title in the console, indicating that this is an AI-powered Excel translator. I enter the code that prompts user to enter the Excel file path. I declare a string variable and use console readLine to read the user input. Then, trim the input to remove any extra spaces or quotation marks. Next, the user has to enter the target language for translation. Again, I use console readLine to read the input and store it in another variable. After collecting the inputs, I validate them using if conditions. First, I check whether the file path is null or whether the file does not exist. If it is invalid, I display an error message and exit the method. Then, I check whether the language input is empty or invalid. If it is, I display a message and exit. I also verify whether the Azure OpenAI API key is provided. If it is missing, I print an error message and stop the execution. Once all the inputs are valid, I use a try-catch block to handle any runtime errors safely. The translation process is performed in the try block. For this, I define another helper method, translate Excel content, which uses the Syncfusion .NET Excel Library and Azure OpenAI to translate the Excel data. In this method, I first initialize the Excel engine. Then, create an application instance from the Excel engine and set the default Excel version to XLSX. Next, I open the Excel file by creating a workbook instance using the provided file path. Next, I define a dictionary called Translation Results to store the translations. This helps avoid sending repeated text to Azure OpenAI. Then, I loop through each worksheet in the workbook. I set used range includes formatting to false so that only cells with actual data are considered, ignoring cells that contain only formatting. Next, I identify the used range of the worksheet using the worksheet used range. From this range, I retrieve the starting row, ending row, starting column, and ending column. These values are used to iterate only through the cells that actually contain data, instead of processing the entire worksheet. I then define a system prompt, which instructs Azure OpenAI on how to translate. It includes rules such as preserving the structure, keeping placeholders intact, and returning only the translated text. Next, I iterate through each cell within the used range using nested loops for rows and columns. The outer loop runs through the rows from first row to last row, and the inner loop runs through the columns from first column to last column. This ensures that every relevant cell in the worksheet is processed. Inside the loop, I first check whether the current cell contains a Boolean value, date time, formula, or numeric value. If the cell contains any of these types, I skip it using the continue statement because these values do not require translation. Next, I retrieve the cell value as text using the getCellValue method. If the cell is empty, skip it to avoid unnecessary processing. For each valid text cell, I prepare a user prompt based on the cell content. To perform the translation, I define another helper method. This method interacts with Azure OpenAI to retrieve the translated text. In this method, I first initialize the Azure OpenAI client with the endpoint URL and API key. This client is used to communicate with the Azure OpenAI service. Next, I create a chat client using the specified model to handle the translation request. Then, send the request to Azure OpenAI by calling the completeChatAsync method. I pass two inputs, a system message, which defines how the translation should be performed, and a user message, which contains the actual text to be translated. I receive the response from Azure OpenAI. I then extract the translated text from the response and store it in a variable. Next, return the translated text to the calling method. Back in the translation loop, I use a try-catch block to safely handle the translation process. Inside the try block, I initialize a variable called translated text with the original cell value. Then, I check whether the same text has already been translated using the dictionary's try-get-value method. If the text already exists in the dictionary, I reuse the stored translated result. If it does not exist, I call the Ask Azure OpenAI Async method to send the text to Azure OpenAI and get the translated result. I store it in the dictionary. This helps improve performance by avoiding duplicate API calls. Next, I update the current Excel cell using the setValue method with the translated text. If any error occurs during the Azure OpenAI request, here, I capture the exception and print the error message in the console. I generate the output file path by retrieving the user's desktop location and assigning a new file name. Finally, I save the translated content to this new file, completing the translation process. Back in the execute translation method, inside the try block, I invoke the translate Excel content method and pass three parameters: the Azure OpenAI API key, the Excel file path, and the target language. This method performs the translation process. Back in the main method, I invoke the execute translation method. Finally, I save and run the application. I enter the file path of the document I want to translate and specify the target language. As you can see, the translated document is saved on the desktop. I open the file, and you can see that the content has been translated into the specified language. Now, let's look at some real-world use cases for this AI-powered Excel translator. In global HR, it helps translate employee records and policies for global teams. In international sales, it supports the translation of product details and customer data. In finance, it ensures accurate translation of reports and invoices. It improves collaboration and project management by translating plans and updates across teams. In supply chain, it helps manage logistics and supplier data across regions. And in education, it makes study materials and documents accessible to a wider audience. That's all for the video. I have shown you how to build an AI-powered Excel translator using the Syncfusion .NET Excel Library. You can download the working example for this video from the GitHub link in the description below. I have also shared a link to learn how to obtain a free license key for our document SDK if you are eligible for our community license. If you found this video helpful, like and subscribe to our channel. Thank you for watching.